Okay, so today we are talking about logarithms. I want you to be able to evaluate logarithms, simplify them, and use change of base to convert logarithms, which is kind of a lot, but I love this. This stuff, I think it's really cool. I never understood it when I was in high school, but I think I figured out how to explain it so that it sort of makes sense. I am always going to come back to why. Okay, on logarithm stuff. Why did you get that? Why does that make sense? Okay, but before we get there, every time we learn something, I don't know if any of you have younger siblings, but it's so adorable, you know, but babies learn to walk, right? They're about one, and they learn to walk, but it's so funny when they're about 16 or 17, maybe 18 months old, and then they learn to walk backwards, and they get this amazing look on their face. They're like, I can do it backwards. Okay, like they're so amazed that they can go forwards, but they can also reverse the process and go backwards. And they're just stunned, okay? Everything that we do in math, we do the same way. We learn how to do it forwards, and then we have to learn how to do it backwards, okay? And so for instance, we had to solve 2x equals, I don't know, 74, okay? What did we do to solve an equation like that? You divide by 2, yeah? This is 2 times x, and we do the inverse operation. The inverse of multiply is divide. And so we use the inverse operation of division to balance the equation, okay? So we use an inverse operation. That's what we're doing today. So logarithms are the inverse of exponents. They undo one another. So they are incredibly closely related. And this is like a super huge thing to be able to figure out. And of course, to help you remember, I have a story. Okay. So I don't know, like I've got 3 kids, and for a long time, and for many of you ladies, you'll be in the same place sometime in your life. I had 3 kids who were under 5. Now, one was not in diapers anymore, but I had 2 under 2. All right, I had 2 under 2, and it's a lot. It's diapers all the time, up to your elbows, all the time diapers. So this is an example of logarithmic form. So I have to get you in the headspace of where I was when I came up with this story. Okay, the diapers. That was all I was doing. All right. So this is logarithmic form. You know it's logarithmic form because it says log, okay? Now, this is log base b of a. That's how you read it, log base b. Every log has a base, so you say log base b. Here I would say log base 7, all right? Down here I would say log base 2, all right? So we say log base b of a equals x. So this is log form. It's got a log in it. It's log form. Now, what we want to do is be able to convert it to exponential form because we're better at exponentials. We know them a little bit better. And so I'm going to ask you, because again, I was up to my elbows in diapers. How do you drop a log? You got to understand what I'm talking about. I was teaching potty training. How do you drop a log? So you drop a log, right? You drop a log? You know what we're talking about right now? Yeah? You're dropping a log? Yeah? Okay. And after you drop a log, what do? You flush her down. You give it a swirly. Ladies and gentlemen, that's what you do. You give it a swirly. So if you're in log form, you ask yourself, how do I drop a log? And you say you give it a swirly. So here you go. You're going to start. Now, this is the important part. You're going to start with the base. You're going to circle around the equal sign and pick up your power, all right? So you start with a base b, you circle around and pick up your power, which happens to be the x, and you continue to swirl around, and that is equal to the argument a, Okay? So how do you drop a log? Swirly. All right, so this is what, so funny story again. I came up with this in college. I was teaching at the U of A. And no, I didn't. I was in college, teaching at the U of A, and taught this to my college algebra kids, right? And they're just rolling on the floor because they're like, this is ridiculous. But so I have a student. This was right before spring break. She flies home and she comes back. She comes to my office hours. She's like, I have to tell you a story. And I'm like, okay, go. And she says, so I was doing my math homework on the flight home for spring break, and I'm doing and I'm writing swirly all over my paper. And the dude sitting next to me, he's like, what does that mean, swirly? And so she goes into the story. She tells the dude sitting next to her why she's writing swirly all over her paper. We're going to use it for the rest of this chapter, so we were solving. But, and she says, well, it's so funny because the person sitting next to me turns out to be a math teacher. He says, I'm a math teacher, and this is the worst thing I've teach every year because it just never goes well. He's like, that is the best thing I have ever heard, and I'm going to use it from now on. So it's just kind of a weird thing. But so you will never forget because I had to give you a gross visual, okay? But how do you drop a log? Give it a swirly, all right? And you can see the little swirl, right? Yeah. Makes sense. Okay. So really important you start with the base. It is the base of our exponential. You circle around the equal side. You pick up your power. And it keeps swirling around, and it equals the argument of the log. And this is exponential form. And I know it's exponential because it's got the x in the exponent. So it's exponential, okay? All right. So we also have what's known as the common logarithm. Common log, how many fingers? 10. Our number system is base 10, okay? And so we have an understood, invisible thing. If you just see a plain old log and you don't see a base there, it is understood that it is log base 10, all right? It's because our number system is base 10, it is understood. So it's important that it is not a 1. It's not an invisible 1, it's an invisible 10, okay? So it's called the common logarithm. That is the log button on your calculator. That is log base 10 right there on your calculator, so that you know that. So we want to write each equation in exponential form. So again, this is logarithmic. How do you drop a log? Swirly. So you're going to circle your base, you're going to swirl around the equal sign, pick up your power. So you have 7 to the second power, and that's going to equal 49. Does that make sense? Does 7 squared equal 49? Yeah, do the rest. How do you drop a log? Give it a swirly. Do the rest. Do number 6, yeah. Shouldn't take you long. Okay, you should be done because I'm done. Okay. So as you circle your base and swirl around and pick up your power, do all of yours match? But more importantly, do they make sense, right? So everything I'm going to talk about here is, does it make sense? Does 4 to the negative 3 equal 1 over 64? Can we check? Yes. Okay, it does. So that negative exponent creates the fraction. And then 4 to the third power, 4 to the third power is 64. 4 to the negative 3 power is, math frac, 1 over 64. So it does make sense. Here we have a rational fractional exponent. Just to remind you, because I know it's been a very long time, this is power over index. So this is the square root of 9 to the third power. What is the square root of 9? 3. And what is 3 to the third? 27. So does 9 to the 3 halves make sense? Equals 27. Makes sense. And again, here we have 8 to the 1/3 power. Well, what is a 1/3 power? Cube root, yes. Again, this is a power over the index, the little elbow in a cube root. So the cube root of 8, what is the cube root of 8? 2, all right? So it does make sense, but more importantly, you can check them on your calculator. Absolutely, these should make sense, yes. Okay, so now we have our equations in, what form is this? Exponential form. How do I know? Yeah, exponential form. How do I know it's an exponential form? Because there's exponents, yes. And so, in exponential form, well, my base is always the base. So this is going to be log base 5. And then we equaled our argument. So this is, argument is 25, and our power was 2. So I can't do it backwards. I don't know. My students, it messes up my brain. But I can write this out and what I think it's supposed to be. Can I double check with a swirly? Yeah, I can absolutely check with a swirly. So start with my base, circle around, pick up my power, and that equals the 25. So yes, I did write it out correctly. All right, so go ahead and finish through 12. It's easy to figure out what your base is, so that's good. All right. So this is a real important one right here. The log of 1, the log of 1, the log of 1 equals 0 every single time. And that's important to know and use. We're going to use it when we're graphing. You can see if I type in the log of 1 in my calculator, it is 0. It always is 0. It's one of those fun things you get to memorize. Hopefully it'll make sense here in a second. So why does that make sense? The log of 1 is 0. Well, because if you give it a swirly, 8 to a power of 0. What is 8 to a power of 0? 0. No. 1. That's the rule. Yeah. Anything to a power of 0 always equaled 1. And so that's why the log of 1 equals 0. They're swapped. They're inverses, okay? So that is a really big rule that you want to pay attention to. Here again, if I think about swirling it, giving a swirly, 10 to the negative 1 power, oh, that creates the fraction 1/10. So I know that I did write that the right way. So again, you can check using a swirly, which is kind of nice. All right, now it's your turn to evaluate the logarithm using our knowledge. Yeah, so this has to equal something. So log base 6 of 36 equals what? Well, I'm going to go back. I suck at logs, but I'm better at exponentials. So again, I'm thinking, hey, 6 to what power equals 36? 2, yeah, so this is just 2. 6 squared equals 36, all right? So again, here, I'm starting with the 2. 2 to what power equals 128? 2 to the 7th, yeah, because 2 to the 7th equals 128. Can you use your calculator to double check? Sure. Turn the page. Hey, what's the base on number 15? 10. There's nothing there. It's a base 10. So here, this is going to equal something. 10 to what power is going to result in a fraction? Negative. It's going to have a negative, absolutely. And 2, yeah, so 10 to the negative 2 power is going to equal 1 over 100. We're squaring the 10. That gives me the 100. I want a fraction, so I make that exponent negative. All right. Here, 16 is my base. 16, how do I start with a base of 16 and get something smaller? A fractional exponent, yeah. So, I can go either way. 2 to what power gives me 16? 2 to the 4th, but I want it as a fraction? 1/4, yes. So 16 to the 1/4. So if my base is bigger, I have a big base, I'm going to have a fraction for my exponent there, okay? Big base, small argument. All right, number 17, I'm starting with a 3. 3 to what power gives me 1 over 27? -3, very good. Again, fractions. If I have a fractional argument, then I'm going to want a negative exponent. And again, always you can check with the exponents. It's really nice. Hey, what's the log of 1? 0. Okay, easy. Why? Thank you, because 8 to the power of 0 always equals 1. So that's the why every single time. All right, some logarithms are not as easy to evaluate as those above. These were all very friendly. They're nice exponents and powers that we've used for really quite a few years, but they're always not so nice. Some logarithms are not as easy and will require the change of base formula. It turns out that the change of base formula, log tall over log small, is how a student of mine said it once. Log tall, log of A over log of B. B as in the small subscript, so log tall over log small. Is the change of base? You'll notice here, what base am I using for these logs? 10, yeah. So what we've done is we've converted to a base 10. So I can just use my calculator to evaluate those from there. So on this one, number 19, we want log tall, so that'd be log of 34 over log small, which is 5, all right? Pretty much, but then you put it in your calculator. And we want to go to 3 decimal places. 3 decimals, please. Once you get used to it. So we're just going to do log 34 divided by log 5. So that is approximately 2.191. Well, how do we know if we did it right? Can we check it? Can we go 5 to the power of 2.191 should equal 34? Should it equal exactly or should it be close? It's going to be close. So 5 to a power of 2.191, and I should get, look at that, that's pretty darn tootin' close to 34. Okay. If I did 5 to the, and actually took that exponent, it is 34. Okay. Pretty cool. All right. Let's see. Will you do one more? We'll just do the next one. Log 98 over log 2. .615. That third place would round up to a 5 there because of the 7. All right? Easy? That's easy, right? Okay. So we also have the natural logarithm. The natural logarithm is it's written as, it has a log base e. Anytime you see log base e, We simplify that because we're lazy, and it is just called the natural log. Now, why is it ln and not nl, natural log? Because it's Latin. All right, so there was Latin first. That would have been Logarithm natural or something like that. Like, right? So who knows? But so that was the the noun before the adjective there, is why it's backwards. Okay. This is an L. It looks like an I. I've had so many students say to me, "What's I in?" Like, it's an L. Yeah, and it's fine. I get it. That's why I always do a script L, so that you know that it's an L. All right. So this is just natural log of x. So anytime you see natural log of x, you can think, oh, it's log base e. So those trade in and out. So natural log is the same as log base e, and we will use those interchangeably. So using the natural log, I'm missing how do I write this in exponential form? I don't have a base. Well, it's really log base e of x equals 4. Natural log gets replaced with log base e. And so what is its exponential form? Oh, how do you drop a log? Swirly. So start with your base of e, swirl around, and pick up your power of 4. Keep swirling, and that equals the x. Number 26. Again, natural log. I'm missing my base. It's really log base e of 10 equals x. How do you drop a log? Swirly. So e raised to the power of x is got to equal 10. So we're just writing it in exponential form. Number 27, how do we write it in logarithmic form? So logarithmic form means that we've got to have a log in there. Log base e of 50 equals the x. Can I clean that up a little bit more? Log base e is really natural log. And anytime someone says ln, I go right to ln DeGeneres. Like, so I prefer you actually say the whole word natural log. We're not talking about ln. This is math class, and ln does not belong. But natural log does. All right. Here we have our base of e, so log base e of x equals our power of 0.5. And again, just to clean it up, log base e is really the same as natural log of x equals 0.5. So this is the best answer. Approximate. So approximate is code for use your calculator. So this is natural log of 64. Again, we're going to go to 3 decimal places. So you have the natural log button in your calculator right here. All right. So we just get to type in natural log of 64, and it's 4.159. Beautiful. And then the natural log of 1/3, whoops, daisy, I need the extra parenthesis there, whoops, is 0.099, yeah, negative 1.099. All right, do you guys have any questions for me? All right, read the directions. It is a worksheet today. Make sure you read the directions, please. It's a super short worksheet, too, which is why we did all the notes.
Is that why we're doing odds now?
No, heck no. You'll finish this in no time. This is for Wyatt.
Shouldn't be that bad, so you know what you're doing?
Brody, did you get the worksheet from Friday?
Yeah, I got it.
You got it before? Okay.
I think I got the hang of it. I was watching the video, so
Oh, good.
it's pretty easy.
Good. Okay. Let's go. Look at your notes. Read the directions.